So we're going to talk about solving simple exponential equations. And this is going to be a subtle introduction to logarithms, although the logarithm part's not going to make any sense. So just roll with that. Okay, so what are we doing here? I want to find the x value. So I'm finding the power such that if I give you a base, you tell me what I would raise that base to get this value. All right, so I give you a value and you just tell me what I'd have to raise the base to get that. And I'm going to give it to you in a weird way. I'm going to give it to you as the base is a subscript, and then what the subscript is attached to is the actual result. It's the value I want at the end. Okay, and that's the subtle part that's an introduction to log. So again, it's not going to make any sense. So just roll with it. So this notation, 2 subscript 8, really means 2 to what power equals 8. All right. Well, we know 2 cubed is 8, so we know the answer is 3. But let's go through it. When you set them up, since you're going to solve an exponential here, 2 to what power equals 8 means 2 to the x, which x is a variable, equals 8. And then when you solve these simple exponentials, just get like bases. So you know 2 or 8 is 2 cubed. So once you have the same base, right, 2 to the x equals 2 cubed, then x has to be 3. So we just figured out that, yes, in fact, 2 cubed is 8. Okay? All right. Let's try this one. So I have 1/2 to the 1/4, or not to the 1/4, but 1/2 in this weird notation is a subscript, and here's 1/4. So what does this mean? It means 1/2 to what power equals 1/4. So set up our simple exponential. 1/2 to the x, I know what the power is, equals 1/4. Again, get like bases. So I know 4 is 2 squared, so I know that 1/2 squared is 1/4. Right? Because 1 squared is 1 and 2 squared is 4, so 1/2 squared has to be 1/4. And now that I have like bases, I don't want that yet, then 1/2 to the x equals 1/2 to the 2. So x has to equal 2. All right. Okay, so this weird notation, set them up as simple exponential equations, and then your job is to get like bases. All right, so you want to stop this and complete classwork problems 1 and 2. Okay, so let's talk about some negative powers. We're going to do the exact same thing, right? We're just going to have different variations of powers here. So I have 5 as a subscript and then 125. So this means 5 to what power equals 125, which is weird, right? So 5, if I raise it to some power, actually turns into a fraction. That's a little strange. But set up your exponential. So 5 to the x equals 125. All right, well, you know right away that 125, 25 is 5 squared. Let's do our same trick. That's 1/5 squared, right? So 1 squared is 1, 5 squared is 25. So that's 125. All right, and now I have 5 and 1/5. I need to make this a reciprocal, right? To do reciprocals, we do negative exponents. So a negative exponent will take the reciprocal, in effect, be the reciprocal of that value. So 1/5 is the same as 5 to the negative 1. So it's 5 to the negative 2. And now that I have like bases, I know that x equals negative 2. So it turns out 5 raised to the negative 2, the negative makes it 1/5, and then the square squares it. So 1 squared is 1, 5 squared is 25. All right. Okay, so let's try this one. So now I have a base of 1/2. So what would I raise 1/2 to get a 2? And that's what that means. So 1/2 to what power equals 2? So I'll do 1/2 to what power? That's x equals 2. Now you can see I'm right onto I have a 2 as a whole, and I have a 1/2. So I want the reciprocal of this. Well, how do we get reciprocals? Negative exponents. Well, 2 to the negative x equals 2 to the 1. So in order for negative x to be 1, x has to be a negative 1. So 1/2 to the negative 1 equals 2. And in this regard, you can really see how a negative 1 is just a reciprocal. So 1/2 to the negative 1 is just 2, the reciprocal of 1/2. Okay, so let's stop this. You want to complete classwork problems 3 and 4. Okay, so let's try this one now. How about I have 9 as a subscript and then 3. So this means 9 to what power equals 3. Right, so actually I'm going to take a 9 and make it a smaller number. That's interesting. So set up our exponential. So 9 to what power? 9 to the x equals 3. Same thing, get like bases. I'm not going to turn a 3 into a 9, but I can take a 9 and make it a 3. So 9 is 3 squared, and that's power raised to power, so that's 3 to the 2x. And how do I get a 2x to be 1? X has to be a half. right? So x equals 1/2. So 1/2 is actually the same thing as square root. So square root, or 9 to the 1/2 is square root of 9, that's 3. Okay, so it shows you how those the rational exponents are actually radicals. Okay, let's try another one. So now I have 1/8 as a subscript and then 1/2. So this means, right, that weird notation means 1/8 to what power equals 1/2. Let's set up our exponential equation. And now I know 8 is 2 cubed. So this is the same thing as cubes. So I get 1/2 to the 3x, right? Because, right, 1 cubed is 1, 2 cubed is 8. So there you go. Now I have like bases, 1/2, 1/2. So how do I get a 3x to be a 1? X has to be 1/3, right? So I'm pretty much dividing, here's 3x and 1, divide both sides by 3. You get x equals 1/3. All right? Okay, so now you want to complete classroom problems 5 and 6. Okay, let's do our last one. So I have 32 and then 1/2, and it's weird notation. This means that 32 to what power equals 1/2? Well, let's set up our exponential equation. Again, I want like bases. So I know 32 is 2 to the 5th, right? And now look, I have a 2 to the 5th, and I have a 1/2. So I want this 2 to be a reciprocal. So once I have a base of 2 to the 5x, and I want a 1/2, I can make this 2 a reciprocal. I can either do a reciprocal here and make this 1/2, or I can change this 1/2 into a 2 by doing a negative, right? So I did the left side. So take your 2 and make it a reciprocal of 1/2, and that's where this negative comes from. There you go. So 1/2 and 1/2 like bases. How do I get a negative 5x to be a 1? Well, x has to be negative 1/5. Okay, so 32. So this is really saying 1 over 5. The 5th root of 32 is 2, and then the negative makes that 2 a 1/2. Okay, let's do our last one. So I have 1/9 and then a 3. In this weird notation, that means 1/9 to what power equals 3. Set up your exponential. Same thing here. I can make my 9 into a base of 3. So 9 is 3 squared. So I have 1 squared, 3 squared. This is really 1/3 to the 2x. Because that square here, 1 squared, 3 squared. And now I have a 1/3 and I need a 3. So let's do the reciprocal. The reciprocal of 1/3 is 3. And I'll change it with the negative sign here as the power. So negative powers are reciprocals. And now I have a 3 to the negative 2x and 3 to the 1. So how do I make a negative 2x a 1? That's it. X has to be negative 1/2. Right, so I pretty much just divide both sides by 2 in the powers if I set the powers as an equation. All right, and that's it. All right, so stop this and complete the rest of the classwork.